Assalamualaikum and hello. Let's continue with how to describe or explain the boiling point for carboxylic acid based on case 2. So if you see here, you got methanoic acid and butanoic acid. If you cannot imagine what is the structure for this one, I hope you can start by drawing the structure, so that you can see it very clear what we are talking about. So methanoic acid is a carboxylic acid with one carbon atom. So I'm going to draw the structure for that. C double bond O attached to OH, and this is H. So methanoic acid, one carbon. Next one, I have butanoic acid with C double bond O attached to OH, and you got CH2, CH2, CH3. So this is butanoic acid with 4 carbon atoms. The next step, don't forget to label. I'm going to label this one as unknown A, butanoic acid as unknown B, so that it's much more easier for me when to explain in bullet points. So how I want to comment the boiling point between A and B. If you take a look here, the first step, you have to know whether both of them can form hydrogen bonding or not. As you see here, both of them are carboxylic acid. Of course, both can form hydrogen bonded dimer. So can we use that as our reasoning? No. So the last step, we are going to use our explanation based on their molecular weight. If you take a look here, you got 1 carbon for methanoic acid. You got 4 carbon atoms for butanoic acid. So you can see that A has smaller molecular weight than B. So that will be your first bullet point. Next one, from the smaller molecular weight, what can you understand here? We are comparing between this alkyl group. So if you see here, methanoic acid got only this one, but butanoic acid got this long. So which one is much more stronger? So the forces that we take a look here is London dispersion forces, because both structures got one functional group, so there is no difference with this reasoning. That's why I use London dispersion forces to show about attractive forces based on alkyl group or hydrogen atom. From that, I use A as my subject, so A can form weaker London dispersion forces than B. That will be your second point. And the last point, you can conclude that A has lower boiling point than B. So this is how you want to compare the boiling point between two carboxylic acids based on case 2. That's it for this video. I'll see you in the next one for case 3.